Are we on? Okay. How are you, everyone? How is life? How is the lockdown taking you? Here I am today for cardiovascular system and the volume. Here I am today for cardiovascular system, and actually with this part we shall see a lot of aspects. When I talk of cardiovascular system, cardiovascular system. Today we are looking at what we call cardiovascular system. When I talk of the word cardiovascular, what do we mean? Cardio, only the word cardio means heart. Heart. Only the word cardio means heart. The word vascular. Vascular means, actually, this one means bloody vessels. So, when someone talks about cardiovascular system as a topic, we shall look at two different things. That is the heart and the bloody vessels. Are we together? So, with the cardiovascular system, don't expect me to go away from this. So, when you are commenting, you should comment in line with the topic. Right about now, since we are looking at both these parts, allow me start with the bloody vessels. Allow me start with the bloody vessels. With this topic, it is one of the simplest topics we have under anatomy as a course unit, because it is an eye opener to the course. Most of them run away from the course because of this topic, but it's very simple if you concentrate and believe in what actually you can do. So allow me look at bloody vessels. Now, this is the first part of cardiovascular. Blood vessels are actually, I can call them tubes found in the body that help in transportation of blood. They are blood vessels. Actually, these blood vessels are those tubes found in the body. You see, that help in transportation of blood. Recently, when you are still in your P7, used to talk about P7 and senior 4, used to talk about arteries as one of the blood vessel. You talked about veins as another type of blood vessel. Are you together? Later, you also talked about capillaries. Capillaries. You also talked about capillaries as another type of bloody vessel. These are the ones you knew by then. But when you come to the medical world, we add more too. That is what we call the arterioles and the venules. Yeah. The arterioles and the venules. So, as I discuss this, I'm going to I'm going to talk much about these four blood vessels. But you must put in mind that under arteries, we shall see other types of blood vessels. Allow me now try to give you a summary of how these blood vessels actually work in the body. This must be at the back of your head. Let's look at this. Remember, we must know that arteries always carry blood away from the heart. So, this is our artery. It's very big. You realize that as arteries move, they usually branch and they form what we call the arterioles. Now, having formed the arterioles, these arterioles will convey blood to what we call the capillaries. And when we reach capillaries, we shall get another type of blood vessel called the venule, which venules will later go back and become veins. This should be at the back of your mind. I said arteries will always carry blood away from the heart. Then they bring it to what we call arterioles. From the arterioles, we shall see capillaries. From the capillaries, we shall see the venules. From the venules, we shall see the veins. Therefore, these are the blood vessels we have in the body. From the heart to from the heart back to the heart. That is the summary you should put in your head. So, allow me now discuss much each type of blood vessel, going deep into every type of blood vessel. Having actually understood what blood vessels are and how important they are in the body, allow me start with the arteries. Arteries. When someone talks about arteries, what do we mean with arteries? First of all, arteries are blood vessels that carry oxygenated blood. They carry oxygenated blood. That is one. In so doing, as they carry oxygenated blood, they are doing what? They are carrying blood away from the heart. Away from the heart. You know, these things are very funny. They don't like things. People actually call anatomy. Science in what we call anatomy, the science is just about that you just have to love what you do, then you enjoy it together. So, they carry blood, they are carrying it in the heart, it can lose the oxygen. Now, what else should we talk about? These arteries actually are made of what we call raffle walls, and this one is made of walls. These walls are actually act as an advantage to withstand high pressure of blood coming from the heart. Are we together? You guys should actually adopt to the new system, of actually accepting to learn from media. Just accept to learn online. So allow me further continue, and I tell you that arteries are also actually made up of 3 layers. They are made up of 3 layers. When I talk of 3 layers, what do we mean? This is what I mean. The artery itself is made up of 3 layers. This is what you should know. That is our artery. So, our first layer is what we call the tunica and the ventitia. Our second layer, what we call the tunica, media. Then the innermost layer is what we call the tunica intima. So with the three which can be abbreviated into AMI, adventitia, media, intima. Yeah, with these 3, each has got its own characteristic. We must appreciate that the tunica adventitia is made up of virtually fibrous connecting tissue for some reason. It's made up of fibrous connecting tissue for protection. That is one. The tunica media is made up of what we call a smooth, elastic muscles. As I was discussing for you, actually, the vascular system, I must have talked about these muscles. So, these smooth, elastic muscles actually are very important in actually controlling the expansion and the contraction of a blood vessel. Therefore, the tunica media of any blood vessel is the one that controls the expansion and the contraction of a blood vessel. Are we together? So, if I proceed and I talk about the tunica intima, now the tunica intima is made up of what we call a squamous epithelium, squamous epithelium tissue. Now, with the squamous epithelium tissue, you must have that it's made up of blood cells. That cells give a smooth flow of blood. Are we together? That is if I talk about the layers of the arteries. So, allow me also tell you that these arteries have actually got a narrow lumen. I've got a narrow lumen. Their lumen is so narrow. Their lumen is so narrow. So, having talked about a little about arteries, allow me tell you that as blood comes out of these arteries. It enters what we call arterioles. Therefore, arterioles are actually sub-branches of arteries. They are smaller arteries in the body. So, what are some of the characteristics of arteries? Still, actually, of arterioles. They also carry oxygenated blood. They carry blood away. They also have 3 layers, as I told you there, and they also have a narrow lumen. Yeah, but there is one special characteristic about actually this arteriole. These arterioles are actually made up of walls that are actually smooth in nature. You will find that these arterioles just actually convey blood away from they convey blood to the capillaries. What do I mean with this? As I told you, that actually blood comes from the arteries, it is coming without of pressure. Therefore, as it comes to reach the veins, to reach the arterioles, this pressure will be reduced by the arterioles. Therefore, hence the name resistance vessels. So these are also called resistance vessels because they always try to reduce the pressure of blood coming from the arteries. Are we together? So that is another name for actually of arterioles. Now, with this, hope now someone knows what arteries are and arterioles are. The only difference with these ones that the layers of the arterioles are actually similar. They are similar to each other than the layers of the arteries. So, when I talk of a thick, rough, or thick walls, I mean that the layers here that make up arteries are very thick. Now, those of arterioles are very thin. Therefore, these arterioles just transport blood. There is no need of them actually being thick because by the time they receive blood, it will have reduced pressure. So, allow me now look at other branches of arteries. So, as a question, someone can tell you, discuss or outline or explain, give brief notes about arteries, and they give you 15 marks. You don't stop here. We have other arteries in the body. They are what we call the anastomosis. We have what we call the anastomosis in the body. These anastomosis in the body are these arteries that carry blood away from the heart in case the main artery is occluded. These ones are arteries that create a link from the main artery. In so doing, they create a link from the main artery, and therefore they always carry blood away from the heart in case an artery, the main artery, is occluded. Do you have people online? Yeah. In case an artery is occluded. So, I want you guys who are online to always comment with the questions. Comment with the questions. Yeah. It makes me happy. After the discussion, I can answer those questions in our WhatsApp groups. So, these the anastomosis are actually vessels that leak from the main arteries. That is one. And in so doing, they always carry blood away from the heart. But that is in case an artery is damaged or occluded. What do we mean? We have some anastomosis in the palm. In case there is a damage here on the main artery here, why is it that I will always still have blood going to this side? It is because of the presence of anastomosis. So, as this is artery, this is an arteriole, the presence of anastomosis actually create these anastomosis we are talking of will always help to carry out what we call arterial saturation. The saturation that has been done by the main artery will be done by the anastomosis. So, in case I get damage, that artery that always helps to carry blood to this part is what we call anastomosis. So, anastomosis are actual arteries that carry blood away from the heart, in case the main artery is damaged or occluded. Allow me to continue and also talk about what we call the end arteries. With the end arteries, when someone talks about the end arteries, what does that person mean? I'm trying to be brief this topic because I think I've discussed it actually many times. Those of you who know that I've discussed this topic many times. And the question comes from here and you fail it, it's up to you. So let's look at what we call the end arteries. Now, with the end arteries, this is the fact that these end arteries that lack anastomosis. So, when someone talks of an end artery, is that artery that lacks anastomosis. Remember, at our back of the head, we must know that this is the way blood flows. Comes from arteries, goes to the arterioles, comes to the capillaries, comes to the veins, comes to the vein. So, remember, we talked about this and called them anastomosis. Now, what are the end arteries? These are ones that lack anastomes. So, these ones actually usually found on the retina of the eye. So, when I talk about end arteries, let me try to explain to you what they are. In case there is damage on a blood vessel here, are we together? And blood is flowing to the palm. Due to the fact that this blood vessel lacks anastomosis and it is an end artery, it will lead to death of this palm. So, that shall come back and add to our definition of end arteries. End arteries are arteries that lack anastomosis, and in the case of any damage to the tissue, it can actually lead to the death of the whole tissue. Or in the case of any damage to the blood vessel, it can lead to the damage of the whole tissue. So, for example, if anastomosis lack this, actually, end arteries lack anastomosis. In case there is a cut here, blood will not flow to this side. Therefore, it will lead to a damage to the tissue. If it is here. Are we together? So, having discussed about arteries, allow me to proceed now, and I look at what we call veins. Now, let me look at veins. With veins, I don't discuss much. It's just the difference. There's just a little difference between arteries. So, with the veins, you must appreciate that veins are blood vessels. Actually, blood vessels that carry blood actually towards the heart. They carry blood towards the heart. That's one. Veins are made up of thin walls. Thin and smooth walls. Veins is so carrying blood towards the heart. They carry deoxygenated blood. You must appreciate that all the veins are made up of 3 layers. Are we together? 3 layers. That is the tunica, adventitia, media, and the intima. The only difference with the structure of this that all the layers here actually have got the same thickness. Are you together? They are not so rough like in the arteries. Are you together? So, if I proceed and talk about veins, the only major difference with arteries is that the veins have got what we call valves to prevent the flow of blood. Remember, as blood comes from your feet, it is coming to the heart. That helps it not to go back to the feet and these valves. So veins are what? Valves. If I further proceed and I talk about the veins, veins have also got a wider lumen. Have got a wider lumen. So with this, a person has to know very well the veins. And the some branches of veins are and venules. So the venules, these ones actually also carry blood towards the heart, carry the blood. Also have 3 layers. The only difference is with the venules, actually them having these valves in them. As blood comes out of the capillaries like this, as blood comes out of the capillaries here. Now this blood is having low pressure. In the presence of these valves, they will always give strength to this blood, so that it can go to the veins and then back to the heart. Hence the name capacitancy vessels. So these are called capacitancy vessels. With capacitancy, we mean giving much energy to the blood. Again, so we have now seen the other name of arterioles as resistance vessels. Now here this one's called capacitancy vessels. Now those are 2 types of blood vessels I've discussed very well. 2 types, but even giving their branches. Allow me proceed and now look at what we call capillaries and the sinusoids. Let me get some chalk. With the capillaries and the sinusoids, capillaries and the sinusoids. When someone talks of capillaries and sinusoids, first of all, capillaries are sites for gas, actually, are sites for exchange of materials, not only gases. They are sites for exchange of materials. Are you together? So, having known that these are sites for exchange of materials, you must always get to know that, these capillaries are actually areas where the blood will always lose what it has, the nutrients it has in it. So, there is a question which is asked about the capillaries, and it's very tactical. They usually ask, and they say, explain the gaseous exchange of materials at capillaries. Which one I'm going to do it for you right now. So, the guiding question they are looking at, these are sites for exchange of materials. But you must understand the sources are usually found in the liver, the endocrine glands, they are mainly found there. They are leaking, they are more leaking than the capillaries. Are you together? So, they are leaking than capillaries. That is what you must know about that. So, the guiding question is, explain the gaseous exchange of the gaseous exchange of explain the gaseous exchange at capillaries. So this is our guiding question. For example, it has 12 marks. How do we go about this question? This is the science about this. You must always appreciate that in the body we have blood, right? Which blood is actually having a pigment called hemoglobin, right? Hemoglobin. Now, this hemoglobin is the already pigment of blood, and it always has a higher affinity to oxygen, right? Therefore, as blood leaves the veins back to the heart, it is deoxygenated. Now, we want to explain when it is actually when it gets back the oxygen, what happens? So remember, it has come back from the veins. It is coming back to the heart. Now it is coming back to the hemoglobin and the oxygenated blood. So when it reaches the heart, it will be pumped to the lungs by the help of what we call the pulmonary artery. The pulmonary artery is actually separate and take one to the left lung and the other to the right lung to pick oxygen. Now, the oxygen will find the hemoglobin in blood and they form a very unstable compound. For those of you who did chemistry, you must know when we talk of instability, we use half arrows. A very unstable compound called oxyhemoglobin. compound is very unstable. So now we have seen that blood has gained oxygen. It is having what we call oxyglobin in it. It will come back to the heart via the pulmonary veins. When it reaches the heart will actually, through what we shall see, some side we shall see, the conducting and the cardiac side somewhere, the heart, by help of those two, will actually now pump blood to all the body parts. All together, by the help of the aorta. Aorta is one of the major actually artery we have in the body. So when blood is pumped out of the aorta, it will come to the, now it is in the aorta, which is the artery. It will come to the venules. It will come to the venules, then it will reach what we call the capillaries. We must know capillaries are actually made up of endothelial cells. Endothelial cells. So when it reaches capillaries, here it will proceed to the venules, then back to the veins. Now, by the time it reaches the veins, it will be the oxygen. Now, it came oxygen. That means there was this oxygen from here. How, where, when? Here we come. So, as you go about this number, you always talk about blood containing a very unstable compound called hemoglobin, which actually is transported back to the heart to combine with oxygen at the lungs. It forms a very unstable compound called hemoglobin, which is transported back to the heart and then taken back to the whole body. Alright, together, when it reaches the whole body, we shall realize and appreciate that this blood will actually reach the capillaries. Now, the moment the hemoglobin reaches the capillaries, due to the high affinity of oxygen to live for blood, it will always diffuse into what we call the tissue spaces, or what we call the interstitial spaces. Then the rest will continue and diffuse. It will diffuse into these spaces until no it reaches here. It will diffuse further into these cells for cell activity to take place. Which cell activities we must know by now. Are we together? So then by the time blood will reach the venules, it will have low pressure. Due to the presence of the valves, which I talked about, it will be given more capacity, then it will proceed to the veins. Hence, the gaseous exchange of gases at capillaries. Are we there? I believe this thing is very simple. If in normal life, it is very simple. Yeah. So I believe we are there. For reference, you can actually visit the Bible of concepts. So now we know what blood vessels are. We know what blood vessels are at the back of the mind. We know what blood vessels are at the back of the mind. So always, you must know that that is all we can talk about blood vessels. But there are some other things or concepts you must know about blood vessels. So there are two things. Let us talk about another thing. Allow me to talk about the control of blood vessel diameter. Control of blood vessel diameter. Control of blood vessel diameter. So, what happens when someone talks about the control of blood vessel diameter? Remember, these blood vessels usually expand and they contract. What takes place during that? So, this is the fact you must know. When you are actually tackling this number, you always have to start with a brief introduction. Which introduction must not miss the following. First of all, this process depends on the presence of the autonomic nervous system. The control of blood vessel diameter depends greatly on the presence of the autonomic nervous system. What do we mean? Under the autonomic nervous system, it is where we have what we call the vasometer. The vasometer. The vasometer, or what we call the brain. or what we call the brain. Allow me to tell you that the fibers help us to produce fibers, which fibers are 2 in number. We have what we call the parasympathetic fibers and the sympathetic fibers. You must always appreciate that the parasympathetic fibers are those fibers produced under normal conditions. Now the sympathetic are produced under abnormal conditions. These fibers are actually produced from the brain. They are produced from the brain, from a part called the medulla oblongata. So when you study more about the CNS, you'll get to know that the central nervous system. So this is the fact. The contour of blood vessel diameter greatly depends on autonomic nervous system, where we shall say brain. Which brain actually has got fibers. Which fibers? The parasympathetic and the sympathetic fibers. But still, it greatly depends on the presence of actually what you call hormones. Hormones. It greatly depends on the presence of hormones, like adrenaline. Adrenaline hormone in the body. So, as you bring out your introduction, you must talk about the presence of the autonomic nervous system, talk about the fibers, also talk about the hormones. All right, together? So, allow me proceed and actually tell you how this occurs, how the contour of blood vessel diameter occurs. Take a scenario under abnormal conditions. Right now you are normal. You are not at panic, you are just seated. Under abnormal conditions. If someone is from running, what will always happen to the blood vessels? That is what I want to talk about. If someone is scared, what will always actually happen to the blood vessels? So, under abnormal conditions. So, we want to bring out the first view of the contour of blood vessel diameter. Under abnormal conditions. This is what you must know. Always, adrenaline hormone will be released in the body. And it will always increase the speed of blood flow under abnormal conditions. When it increases the speed of blood flow, it will increase the speed. Adrenaline will increase the speed. This is done by the hormone. In everything you talk about here, you must bring out the 3 elements you brought in the introduction. So it will always increase the speed of blood flow. So now, when the blood flow increases, there will always be a change in the fibers produced. Under abnormal condition, I said sympathetic are what? Then the sympathetic will be produced. The sympathetic fibers will be produced. Now, these sympathetic fibers, when they are produced, they will always come and affect what you call the tunica media, because we say it controls the expansion and contraction of a blood vessel. What will happen to that tunica media? First of all, you must always appreciate that when these sympathetic fibers reach the tunica media, they will first of all actually cause what you call the narrowing. They will cause narrowing of actually the diameter. The diameter will narrow. That is one. Diameter narrows. After the diameter narrowing, we shall see that also the thickness of the walls will also do what? Enlarge. Are we together? Are you getting me? Now the thickness of the walls will enlarge. So, having seen that the thickness of the walls has enlarged, are you together? Now, this is all caused due to it is actually caused due to increase in nerve stimulation from the brain. And all this is what we call vasoconstriction. Are we together? This is caused due to increased stimulation. So, when you talk about the control of blood vessel diameter, at the back of your mind, you should always talk about actually the vasoconstriction. First, let's talk about the other term we are going to get to see. So, allow me actually tell you that this number is very simple. If you also take things very easy, it becomes very simple. Allow me to tell you that when we are discussing this number, we usually look at these three things. So right now we discuss part two of the question. In case now you are under normal conditions. First, like right now, under normal conditions. Don't care. I'm doing everything at my pace. So under normal conditions, first of all, the parasympathetic fibers are produced. Are we together? Even the blood flow will be low because the adrenaline will be produced at the normal rate. So when the parasympathetic fibers are produced, they reach the tunica media. What will they do? They will do the opposite. Here, instead of actually narrowing, they will enlarge. They will widen the diameter of the blood vessel. Diameter will widen. When the diameter widens like this, there is always thinning. There is always thinning of the vessel walls. The vessel walls enlarged because now this is the science about it. As you try to fix blood into here, under no conditions, blood will flow properly. So the diameter will be enlarged properly. As it is enlarged, we shall see also these walls also doing what? Trying to think to create more space for the enlargement. And this is all caused due to decreased nerve stimulation. And that's what we call the vasodilation. Vasodilation. So, as we go about this number, you must bring out the following. Talk about the autonomic nervous system, talk about the fibers, hormones, bring out the vasoconstriction and dilation. I'm done with that. Because the topic is somehow wide, I want to discuss a lot of concepts for you people. And you appreciate that anatomy is very fun. You know, when we grow up, I used not to like studies because I was just forced. But now, I am seeing where I'm going. Huh? So whenever you try to reach the mango, if you are climbing up the tree, you get happy. So I'm also happy, excited that I'm reaching the mango. So now that has been the control of blood vessel diameter. Allow me discuss another thing, another concept. This one is now going to be about the capillary fluid dynamics. The capillary fluid dynamics. Now, with the capillary fluid dynamics, this is what you should know. Here, we are talking about the two forces that always help blood to get out of the capillary and also get back into the capillary. So, we have what we call the hydrostatic. That is the first one. And we also have what we call the osmotic pressure. So, with the hydrostatic force, look at this. This is our capillary. So, this is the science you must know about the capillary fluid dynamics. The force that actually helps blood actually to leave the capillary is what we call the hydrostatic force. While the force that helps the capillary that helps blood to come back to the blood vessel is what we call the osmotic pressure. Are we together? So this is hydrostatic, this is osmotic pressure going down. Are we together? That is what I can tell you about those two forces. That is under the capillary fluid dynamics. So With the capillary fluid dynamics, I can come again, and I told you that we shall talk about the two forces that help actually blood to get out of the capillary and get back into the capillary. That is the hydrostatic and osmotic pressure. Are you together? Now, the hydrostatic force that helps blood to go out, or osmotic is that one that helps it to come in. So I think I've discussed a lot with the blood area, but before I proceed, let me try to see whether we have left out nothing according to the syllabus. Let me see. We have left out nothing according to the syllabus. We have talked about the control of blood vessel diameter, exchange of materials. We talked about the forces. Talked about forces. Yeah, I think with blood vessels, I've left nothing there. I've left nothing there. So these things, there is no actually going back to books, check this. I just love what I do. That's why I can actually discuss these things, and I just want to actually check on books for reference. Yeah, that is why I cannot tell you. So, if I can actually further explain a little about this fluid dynamics before I proceed, how it happens and how it takes place. And this is our capillary. When you hear about osmotic pressure, this is not physics, my dear. This is anatomy. Anatomy, a course unit in the medical world, which most of you people fear. Anatomy. Someone listens to anatomy. So there's someone who told me, Manan, I don't know. Whenever I read anatomy, I don't understand. I told them because you don't concentrate when reading anatomy. Yeah. Let me tell you how these two forces work. So, at the back of our mind, we must always know. Actually, we must always put in head that there is the first opposing force that will always be flowing into the blood, into the capillary tube. And this one can actually be 5 kilograms per Pascal. Let me bring it in this view so that you don't get confused. So, look at this. As the blood reaches here, we are going to explain these two forces. There is always that opposing force that is the hydrostatic force, which can be 5 kilograms per Pascal. That will always force blood away from the capillary. Are you together? But still, there will also be another force that will always force this blood to come back into the capillary tube, and this one can actually be 2 kilograms per Pascal. Now, when you look at the resultant force here, now those of you who did physics properly, when I talk of resultant force, you realize that it will be 3 kilograms per Pascal. Therefore, that force, which is 3 kilograms per Pascal, will help the blood to come back to the capillary tube. That is the hidden meaning about these two forces, and you must know about it. So now, as the blood is also going out, now it has been at the beginning, as it is also going out at the venules, at the capillary end, it is the reverse now. We shall see now the opposing force will be now. We shall see that now the opposing force taking blood away can be actually 3 kilograms per Pascal. That one bringing it back can be 1 kilogram per Pascal. The resultant is 2. Still, the same will happen. So, for more reference, visit your anatomy and actually visit your Ross and Wilson, the Bible. So, with all that, I think we must have seen everything. We must have seen everything. We talked about the blood vessels properly. We must have talked about the arteries, arterioles, anastomes, and arteries, capillaries, sinusoids, veins and venules, control of blood vessel diameter. Now, we must have talked about the exchange of materials, and with all that, is what the first part of the cardiovascular. The only part I can actually aside can give is there's a question that you can ask. Explain explain factors. Diameter, viscosity, and length of the tube. You can go look at that as an assignment. So, I look at the part there. Yeah, heart. Disturbing us. When I look at the heart, this is the part. The heart is under the particular part. Actually, with the heart, I need your attention. I'm going to be fast, but one of the interesting parts in this topic. This is what you must always know about the heart. This should be the back before you do anything about it. That the heart, actually, if this is our heart, the process by which the heart sends the blood to the upper parts of the body, what we call the pulmonary saturation. While the process by which blood is actually taken to the systems is not called a systemic saturation. So, in details, this will be seen in details in part 2 of the cardiovascular. This is part 1 of the cardiovascular system. So, allow me to talk about the heart. What define for us heart? Heart is a cone-shaped, hollow, muscular organ. Heart is a cone-shaped, hollow, muscular organ. It is cone-shaped. It is cone-shaped. When I talk of a cone, this is what I mean. It is cone-shaped, hollow. It has got muscles on it, and it is an organ. Together, the heart must always, and we must always know that the heart, the body, is responsible for maintaining a constant blood flow through the body. It is heart. And you must also observe that since it is cone-shaped, this is the tip of the heart. This is the base of the heart. And our heart is located on the left side. Therefore, we must appreciate that the tip is actually down, where the base is on top. Are we together? That is what I can always tell you about the heart. So, when we are looking at the heart, we must appreciate that the heart is actually made up of actually muscles on it. This is for protection. We are going to see or talk much about these muscles. We shall talk much about the muscles. Allow me right now try to tell you where the heart is located in the body. Position of the heart. It is actually a question which is actually asked very much. Position of the heart. Where is the heart located? First of all, you must appreciate that the heart is located in the thorax cavity. The heart is located in the thorax cavity. We know that the body is made up of actually many cavities. Actually, there are around 4. That is the cranial cavity, which keeps the brain. The thorax cavity that runs from the upper trunk of the neck to the diaphragm. The abdominal cavity from the diaphragm to the in between the pubic bone here, in the thoracic cavity. And with the thorax, it is located in the thorax cavity, and it's located on the left side of the rib cage. It is located on the left side of the rib cage. On the left side of the rib cage. And actually, you must know that it is located mid-clavicle or mid-collar bone. It's located in the mid-collar This is the collarbone. In between it, you can actually approximate. Then, it's located mid-collar bone of the rib cage. Submammary. Now, when I talk about this, to the submammary to the breast, in the fifth rib chamber. So, this is the version of a person who actually understood anatomy. Because you have proof about this. Here with me I have a lot of sources. I have around 20 books here, which I can read, pamphlets, but actually all in all, the fact is, many have got the way how they bring out the position of the heart. But a person who knows anatomy must bring out this thing the way I've brought it up. I said the heart is located thoracic cavity, left of the rib cage, medial bone, submammary, that is in between the breast, in the fifth rib chamber. When you count from here up here, you'll find that it is in the fifth rib chamber. That is the first chamber after your breast down. If you touch that, you will see that's where the heart strongly pumps blood, and once it stops, you enjoy, or you take the bucket. So that is with the position of the heart. So having seen the position of the heart, we know the heart, where the heart is located. Now we need to know, how does the heart look like? How does the heart look like? With this part, I want actually to bring out many things. I want to bring out many things to this area. Let us first of all know how the heart looks like. That is the structure of the heart. So I'm going to teach how to draw a two-dimension diagram, which is quite very simple. And whenever they ask you, you should draw. You adapt to the new. Anyway, you can draw anything you want, but this is easier. I try so hard to simplify people's lives. So, when you are drawing the heart, you must always start from the ventricles down. From the ventricles. Now, those are the ventricles. You must appreciate actually, remember here, before you draw the heart, you must look at what is your right hand is left here. Because actually we are looking at the specimen which is looking at us. So this is my right, so it is my left. This is my left, so it is my right side. So you must observe that the left ventricle of the heart has got more muscles than the right ventricle. So as you bring up this, you show this. So the thickness here is quite big than the thickness here. So if we proceed, now we have drawn the ventricles. Let us now put in the major blood vessels here. Allow me start with this left side. I can first put these valves. Are you seeing me? Then I bring this up. Are you together? Then I also bring this. Are you together? So you must appreciate that this is what we call the aorta. The same can be done to this side. You bring out this part. You also bring out this part. This is what we call the pulmonary artery. This is what we call the pulmonary artery. So there is a line separating these two sides. Before you even proceed, what's called the septum. The septum. Are we together? Now, look at this. I want to put valves here. I want to close this chamber. Now, I have got what we call the left ventricle down. I want also to close this chamber with other valves. Also, these valves have got names. The valves closing the aorta are what we call the aortic valves. These ones. The valves here can be called the tricuspid valves. Or another name is going to come with time. I'm going to show you how we can generate that name. Here, this is also called the pulmonary valve. It's what we call a pulmonary valve. Here, this is what we call a tricuspid. It's what we call a tricuspid valve. Are you together? Now we want to put on these both chambers here. Are you together? Now look at this. As we are putting on these chambers, you must know that there are some vessels pouring blood here. Are you together? Then you bring it out properly here. Are you together? Now these are what you call the pulmonary veins. These are what you call the pulmonary veins. So we have now what you call the left atrium. Now we have the atrium chamber here. So the same we do to this side. But now with this side, we must bring out that element that we have got the vena cava being separated into two. So when you reach here, you usually curve a bit, and actually you bring out that element that look at this. Are you together? So we have what we call the superior and the inferior vena. This is what we call the vena. This is what we call the vena cava. So we have what the right ventricle, the right atrium. So as I told you, the blood that comes from the top of the head through a process called pulmonary saturation will pass through the superior vena cava. From the lower part to come through the inferior vena cava. Are you together? Yeah. So now that is the heart. We can look at that, but it is missing a lot of things. So I will tell you another name of these valves. At our level we can call them bicuspid or tricuspid. You can call them another name. Actually, since they are closing two chambers, they are closing what we call the atrium and the ventricle. They can also be called the arterioventricular valves. They can be called the arterioventricular valves. Are you together? It's the same name here. Arterioventricular valves. The left arterioventricular valves, the right arterioventricular valves. Still, when we look at the structure of the heart, you must actually that actually is protected by three layers. It's protected by the outer layer. The outer layer is protected by what you call the pericardium. The pericardium layer. The middle layer is protected by what you call the myocardium. Myocardium layer. While the inner layer, and you must appreciate myo means muscle. So it is this layer containing muscle in the heart. Actually, the inner layer is what we call the endocardium. Endocardium. So, those are the three protective layers of the heart. Are we together? So, in explanation, so when you're on paper, you must be organized. I just want to bring out the view that this thing is very simple. So, allow me now also explain to you, actually, the blood flow through the heart. How does blood flow through the heart? What actually, blood always flows from the upper part of the body, what called the superior vena cava, here, and the inferior vena cava, that is from the lower part. Then it will come and it will reach the right atrium. When it reaches the right atrium, blood will first fill up this chamber. When it is filled, the valves, the arterioventricular valves, the right ventricle valves will open up and it will flow into the right ventricle. Alright, together? So now, when it is also full, they will close and they will force what you call the pulmonary valves to open up, so that blood can be taken to the left and the right lung pick oxygen. So, having picked oxygen, it will come back through the pulmonary veins into the left atrium. When this atrium is full, it will force this to open up to also make the left ventricle get full, and then blood will flow outside the body through the aorta. That is the That is, when someone tells you to explain the internal or internal environment of the heart, you draw this diagram. Two-dimensional diagram is enough. I explain everything. When someone tells you to describe the structure of the heart, I'm going to also bring that in. Whatever I've explained here is in reference in a book called Ross and Wilson. But there are some parts here we cannot see in the two-dimensional diagram. We also have what we call the coronary arteries. These coronary arteries actually found the main arteries. They are coronary arteries. These supply blood to the myocardium. And any damage to this coronary artery will always lead to what we call a heart failure or cardiac arrest. So by now, I believe all of you now know how the heart looks like. And if I can bring out the diagram from Ross and Wilson, the heart actually looks like this. The heart looks like this. This is what this diagram showing. What I told you, that the flow of blood to the upper area is not saturation to the lower area, saturation. You must appreciate that the heart has got other arteries on top, on the layers. So now let's draw the structure so that I come out with the picture. Now, I believe by now you know how the structure of the heart. Okay, allow me to proceed and talk more about the parts of the heart. Now, in the parts of the heart, even before I go any further, allow me to tell you that the heart is surrounded by different parts. Using anatomical terms, I also told you when you talk about the boundaries of different organs, we use words like exterior, posteriorly, inferiorly, anteriorly, lateral, anterior, posterior, superior, inferior. Where we use superior is above, posterior, actually anterior is down, lateral is across. Together. So let us get to know which parts bound the heart, according to the diagram. Using the diagram in reference to the Ross and Wilson, you must appreciate that the heart is actually located between the left lung. The heart is located in between the left lung, and you must also appreciate that the heart on the left lung, therefore the left lung is smaller than the right lung because of the presence of the heart. So when we talk about this view, what is above the heart? Above the heart, if the heart is here, when we close here, we shall always see the esophagus, the trachea, and the major blood vessels that they are located actually above. Are you together? Above the heart, we close here. If we come back to this view, above, if this is the base, I'm seeing the superior vena cava, I'm seeing the pulmonary artery, aorta, the pulmonary vein. So the major blood vessels are located above the heart. Are you together? So below, inferiorly, down the heart, we have the apex of the apex sitting on the diaphragm. So the diaphragm is located below. Posteriorly, behind the heart. Behind the heart, you have the esophagus. Behind the heart, you have the trachea, and also that is posterior, and you also have spinal cord. Anteriorly, actually, that is in front of the heart. We have what we call sternum bone in front of the heart. This is the heart. Here, we have a sternum bone in front. Now, across the heart, what is located across the lung? Because it covers of the heart. So it's the lung. Are you together? So that is the boundaries of the heart. Allow me, actually, having looked at all that, now look at the structure of the the layers that protect the heart. And after looking at the structures of the layers that protect the heart, then I'll go deep into what we call the cardiovascular system, where I shall say the cardiac and the conducting system. Then we call it actually the part 1 of the cardiovascular system. So we are here. I'm going to look at now the structure, the protective structure of the heart. Remember, the heart is protected by 3 layers. 3 layers. That is the pericardium being actually the pericardium being the outside part, the myocardium being the inner part, and the endocardium. So, excuse me. I'm continuing. So, we are looking at now the protective areas of the heart. Allow me start with the pericardium. This is what you must know about the structure of the heart. These are the layers that protect the heart. At first, you will always see what you call the pericardium. Are you together? We shall see the myocardium in between, the endocardium as the innermost part. So, this is what you must appreciate. That the pericardium here is actually made out of the outer fibrous sac. So, you must know that the pericardium is divided into 2 sacs. So, these 2 sacs, one of it is the fibrous sac. This is the fibrous sac. This is the pericardium, the fibrous. It's made up of fibrous connecting tissue for protective reasons. Now, the inner layer of the pericardium is further divided into 2 other layers. So, and these layers are divided by a fluid called serous fluid. Serous fluid. And this fluid actually prevents friction between the 2 layers. Are you together? This thing actually is very easy. We are on the first layer, which is the pericardium. I said it's divided into 2 sacs. The first sac is the fibrous sac. The second sac is divided further into 2 layers. What we call actually the parietal. The parietal is this near to the fibrous. What we call the vessel, which is near to the myocardium. So the vessel lines the myocardium layer. Are you together? So now you must know that now with the pericardium, when I talk about the pericardium, the outermost part of the pericardium is made of fibrous connective tissue. That is actually the outer fibrous sac. Then the inner sac, which is under the pericardium, is made up of 2 other layers. That is the parietal, which is divided by the serous fluid that prevents friction between the parietal and the vessel layer. That is what I can tell you in brief about the pericardium. So, allow me now to look at what we call the myocardium. This is the myocardium. And this word myo means muscles. So, as I always told you, same to the blood vessel, the twin media is not composed of the smooth muscles. It is the same here. This controls the expansion and the contraction of the heart. Remember, this outer fibrous sac does not expand much. So in case of expansion, when it expands to come and knock here, it will not expand more. When it expands, it will not expand more than this. Therefore, this is the expansion and the contraction of the heart. Are you together? So, do you have people online? Yeah, you can comment with actually. Are they commenting with questions? They don't have questions. Yeah, okay. I believe you're actually getting what I'm discussing here. So, now, the muscles composed of fear are called cardiac muscles. And these cardiac muscles actually these are independent of the brain. The brain does not control these cardiac muscles. These cardiac muscles here grow up in actually having what we call a unique feature. These cardiac muscles always have what we call branching cell in them. That's what we call intercardiac discs, which are actually made of nucleus, the intercardiac discs. These cardiac muscles actually grow like this. So this cardiac muscle is made up of actually a branching cell that actually helps to transport impulses in case of need of actually contraction or expansion. There is no need of the heart actually to go tell the brain now we need to expand. No. In the case they need to actually expand, impulses will come here, transport the branching cell to the pericardium. Then the response is seen. Are you together? I told you the cardiac muscle has got a branching cell, has got an incarnated disc, has got a nucleus, it has also got stripes in it. That is the structure of the myocardium. Now with the inner sac, this is made up of actually it's made up of squamous epithelium, and it is made up, therefore it has flat cells on it to provide a smooth flow of blood. Having seen that, having seen the layers of the heart, now allow me now come to this concept. Allow me come to the very important concept before we forget. Allow me look at now. Allow me look at the conducting system of the heart. I have to call the cardiac cycle as well as the heart sound, and you call it. So with the conducting system of the heart. The way you hear the word conduct, how does the heart conduct those impulses through the myocardium? So you must know that this conducting system actually depends greatly on the part of rhythmicity. That is the property of a conducting system. You must also appreciate that it still greatly depends on the presence of fibers. As I told you, it depends on the presence of fibers. Still, you must also appreciate the presence of hormones in the body. So, you must appreciate that the conducting system of the heart actually is separated into how many stages? 3 stages. They are majorly 3 stages. To mention them, that is the sun, the sino, arteriole, the sino-arteriole node, the arteriole, ventricular node, and what we call the AV bundle. That is to mention about the stages. So, as we go about the conducting system of the heart, if we start with the first stage, this is the sun. The sun, actually, you must appreciate that when we see the diagram of actually the heart, it is located in the right atrium near the superior vena cava. So, this is what I talk of. We are talking of the sun, the sino-arteriole node. It's located in the right atrium near the superior vena cava. Therefore, this sun has actually got a property of actually being unstable. It is very unstable. In so doing, it being very unstable, anytime it has the ability of actually becoming depolarized or losing its impulses. So, in case the heart wants to expand, this one will send its impulses. First of all, it is one of the among the 3. It actually produces the most fastest impulses. Therefore, it is the fast pacing maker of the heart. It is the fast pacing maker of the heart. So, its major function, first of all, is to produce impulses. That is 1. 2 is to transmit impulses to the FVN. So, that is what, in brief, you must know about that. So, when you are talking about this number, bring out these 3. Now talk about each. Are you together? As you talk about each, you must appreciate that the sun has a part of being very unstable. Therefore, it has a bit of losing impulses in it. actually faster. Therefore, hence it losing impulses very faster. It is the first pacemaker of the heart, and it's also important in the transmitting impulses to the AVN. When it comes to the AVN is actually located. It's located actually in between the arterioventricular valves of the left and the right. Here, it's located here. That is where we have the AVN. That is where we have the AVN. So, and it's from here we have the AV bundles branching, going over. Are you together? So, what do we mean when we talk of the AV bundle? These are bundles that actually transmit impulses to the myocardium, as I'm going to explain here. So, the AVN is located in between the arterioventricular valves, and its function, first of all, is to receive impulses from the SCN. From the SCN, the other function is in case the impulses produced actually very few, and they cannot actually support the activity needed, they also transmit their own impulses. Hence, they are second pacemakers. They are second pacemakers. Then they later transmit the impulses to the AV bundles. So when we come to the AV bundles, these bundles actually branch, as you have seen, they branch from the AVN. And they actually rotate around the ventricles. And these ones actually transmit impulses to the final stages called the Purkinje fibers. And these Purkinje fibers will always keep these impulses until they are needed by the myocardium. So when they actually, there's need actually for expansion, the Purkinje fibers will transmit those impulses to the myocardium, and hence the expansion will be taking place, or the contraction will take place. That is all I can say about the conducting system in brief. Yeah, I believe these things I'm actually discussing, they are quite very, very easy. So allow me now to look at what we call the cardiac cycle. The cardiac cycle is the same as the heart beat. Whether the heart actually, its actual amount of beats are 72 beats per minute. So, any deviation shows a side effect. Are you together? So, now we are looking at what we call the cardiac cycle. And with the cardiac cycle, you must always appreciate that it takes actually 0.80 seconds. So, and it takes 0.8 seconds to take place. The cardiac cycle of the heart is divided into 3 stages. And this can be shown on a pie chart. So on the pie chart, you must appreciate that the first stage is what you call the arterial systole. So we have what we call the arterial systole. Also have what we call the ventricular systole. Then the last stage is what we call the complete cardiac diastole. When I talk about systole, it means contraction. When I talk of diastole, it means expansion. So you must appreciate that this one takes 0.1 seconds. The arterial systole. 0.1 seconds. Are you together? Now, this one takes 0.3. The ventricular systole, the contraction of the ventricles. Then 0.4 is taken for the complete cardiac diastole. Are you together? So, if actually you know this thing, how it is actually represented, it is very easy for you to bring up this concept. So, allow me to discuss each, tell you what happens in each stage. Under the arterial systole, systole. You must know that it takes 0.1 seconds. That is one. First of all, you must actually know it takes that time. After knowing that it takes 0.1 seconds, you must further know that under the arterial systole, we shall see blood filling up the atrium. And when the atrium is filled up, it will open up the tricapsid valves, that the ventricles fill up. When the ventricles fill up here, when the ventricles fill up, the valves will close. And after the valves closing, it will lead to opening of the aortic valves. So here we shall see both sides fill up with under the arterial systole. Both the left and the right, both the right and the left atriums will fill up with blood. When they are full, they will lead to opening of the valves. When the valves open up, that will lead to filling of the ventricles. And when the ventricles fill up, they lead to opening of the aortic and the pulmonary valves. Those are the stages that take place in the arterial systole. When we look at what you call the ventricular systole, under the ventricular systole, this is very important. Under the ventricular systole, this one takes 0.3 seconds. We shall say under the ventricular systole, it is where the blood now will leave the ventricles and it goes outside the heart. So here we shall see that since the ventricles are made up of very, very muscular walls, blood will be forced to leave through the aortic and through the aorta and the pulmonary artery. Are you together? That is what I can always tell you. So, having seen that blood will leave, we shall see blood leaving. Blood will leave through the aorta and the pulmonary artery. Are you together? Now, when it comes to the complete cardiac diastole, now, with the complete cardiac diastole, you must appreciate that blood will actually have left the heart. Now, we need now the heart walls to relax. Under complete cardiac diastole, we shall see relaxation of the myocardium layer of the heart. Therefore, this takes 0.4 seconds. And having known that, that is what we call a cardiac cycle. Are you together? So, that is what we call the cardiac cycle. Under complete cardiac diastole, we shall see relaxation of the myocardium, which takes 0.4 seconds. And it will lead to a continuous beginning of the first stage. It does not matter which stage you start with. So, having actually discussed that cardiac cycle, allow me actually tell you that the heart is a very important part. And in case there is a damage, I'm trying to check whether we have missed nothing. I believe we have left out nothing. According to what I'm supposed to cover, we have left out nothing. To me, that is it all. Maybe if I can actually relate this cardiac cycle to the heart sound. So, under the ventricular systole, we shall always see, as blood as blood goes out of the heart, we shall always see a louder sound called loop. Are we there? Under the diastole, we shall always see a sound called a do. So the heart has two sounds, loop and loop. Loop and loop. So loop is seen under the systole, the loop is seen under complete cardiac diastole. Thank you for listening. Londo Martin is my name. Actually, I'm so glad to always be fasting with you guys here. I just want you guys to always actually to loving the subject. I wish you well. Stay blessed.